Hello, my name is JooYoung CEO.
I'm Yilin.
We're from the University of Illinois Urbana-Champaign. In this video presentation, we'll discuss our work on MAIDR, making statistical visualizations accessible with multimodal data representation. This project was developed not only by us, but also in collaboration with Bongshin Lee, Sean McCurry, and Yang. In our information-rich society, the importance of data visualization is growing. Despite visualization being an effective cognitive tool, there is an underlying assumption and paradox that it necessitates a visual ability. In essence, what is convenient for sighted individuals turns into an obstacle for blind and low vision people. Visualization inherently has accessibility issues for blind individuals. It's crucial for us to address and offer multimodal data representation in addition to visual modality for inclusivity. To address this issue, there have been related studies. The alternative method to visualization has often been limited to textual descriptions, which are processed through the verbal channel of human cognition. Tactile graphs, another method, have been widely adopted and are processed through the nonverbal channel. There's also sonification, a nonverbal method that uses special audio sounds. Recently, mixed modalities combining text and sonification have gained attention. However, tactile graphs, which require the aid of sighted people to create, have not been fully integrated into these mixed modalities. This oversight has led us to question whether tactile representations could be incorporated into mixed modalities. Our aim is to contribute to the field by exploring the potential for including tactile representations alongside text and sonification, offering a more inclusive approach to data visualization. We're an interdependent design team inspired by my needs as a blind professor teaching data science, which served as a collective source of inspiration. We're a mixed ability team comprising both blind and sighted researchers as well as sighted developers. Together, we embrace an iterative and co-design process where we brainstorm, prototyped, and conducted user studies. Through our collective design process, we established 6 design considerations, DC. Here's a brief overview. DC1, the system should initially support widely recognized data visualizations representing distinct statistical concepts. We concentrated on 4 Cartesian-based statistical graphs. Bar plot represents frequency distribution using 1 categorical and 1 numerical variable. Heat map conveys the chi-square test through 2 categorical variables. Box plot delivers the concept of interquartile range and outliers using 1 numerical and 1 categorical variable. Scatter plot shows correlation with 2 numerical variables. DC2, scalable and adaptable tactile representation should be provided, compatible with single-line refreshable braille displays. DC3, each data point should be navigable by standard 4-way arrow keys. DC4, the combination of mixed modalities should be customizable with a tethered cursor position across modalities. DC5, users should be allowed to adjust information presented in each modality. DC6, layer-by-layer navigation should be enabled for sequentially accessing overlay elements. With these design considerations in mind, we developed a system named MAIDR, which stands for Multimodal Access and Interactive Data Representation. Initially, we focused on implementing bar plots, heat maps, box plots, and scatter plots. Following user studies, we expanded to include other types of visualizations. The MAIDR system requires 2 components from creators, a plot image file and a metadata file containing visual agnostic attributes. For the image file, the MAIDR system accepts both raster and vector formats, although visual highlights are only available for SVG files. The metadata file is a JSON schema detailing the plot attributes such as data points, plot type, and labels. Once both the image and JSON schema files are supplied to the MAIDR JavaScript engine, the system generates a multimodal data representation of the plot as HTML content on browsers, accessible via screen readers and braille displays. Let me specifically explain the accessibility features of our MAIDR system. MAIDR offers three primary modalities: braille, text, and sonification, BTS. Each modality uniquely represents data patterns through both verbal and nonverbal channels. For instance, braille conveys data patterns as nonverbal tactile representations on a refreshable braille display. Text is delivered as verbal auditory information through speech synthesizers of screen readers. Sonification, an auditory nonverbal modality, represents data with spatial sounds. Beyond BTS, we introduce an auxiliary mode called review or R. This review mode offers a verbal tactile representation, enabling users to review data point information in literary braille on a refreshable braille display. Now I will demonstrate how the MAIDR system works. Before doing so, I will briefly explain two assistive technologies used by blind individuals: screen readers and refreshable braille displays. Screen readers are software that reads out information on the screen using speech synthesizers. Refreshable braille displays are hardware devices that translate text on the screen into real-time braille. The MAIDR system utilizes these two assistive technologies as mediums for blind users. In this demo, we will focus on box plots and scatter plots. Currently, a box plot is displayed on the screen. As mentioned earlier, blind users can navigate this visualization by toggling the BTS, braille, text, and sonification on and off. I will activate braille by pressing B, sonification by pressing S,
Sonification on.
and text by pressing T. Once the BTS mode is activated, these modalities tether their cursor positions to each other. Then using four-way arrow keys, I can navigate through each data point.
BST. 25% 71.17. 50% 73.665. 75% 77.555. Maximum 81.235. 0 upper outliers. Europe 0 upper outliers. Asia 0 upper outliers. Americas 0 upper outliers. Africa 9 upper outliers 72.737, 72.801, 73.042, 73.615, 73.923, 73.952, 74.772, 75.744, 76.442. Because
the BTS mode can be toggled on and off, blind users can create up to 8 different combinations according to their preferences. Additionally, as previously mentioned, there is an auxiliary mode called review. By pressing R to activate the review mode, the currently focused data point is left in the text buffer.
Maximum 72.301. R. Read only edit. Maximum 72.301. Review on.
Blind users can then read this information using a refreshable braille display. Next, I will show you the scatter plot. The scatter plot used in our user study is a 2-layer scatter plot. The first layer contains points, and the second layer has a smooth line curve. Our MAIDR system allows the users to move to the next layer by pressing the page up key.
Page up. Switch to smooth.
And to the previous layer by pressing the page down key.
Page down. Switch to point.
In the point layer, sonification supports 2 modes: sonification combined and sonification separate. Sonification separate plays the currently focused data point with a slight interval between them.
Sonification separate. S. Engine displacement 1.6. Engine displacement 1.8. Engine displacement 1.9. Engine displacement 2. Engine displacement 2.2. Highway mileage 26, 27, 29.
In contrast, sonification combined plays multiple data points simultaneously as if pressing a chord on a piano without any interval.
Sonification combined. S. Engine displacement. Engine displacement 2.5. Highway mileage 23, 24, 25, 26, 27, 28, 29, 31, 32.
I'll press the page up key to move back to the smooth layer.
Page up. Switch to smooth.
Here, blind users can listen to the trend line of the current smooth curve through sonification. When Braille is activated by pressing the B key,
Edit test pop-up. Braille on.
users can navigate in detail through the points of the smooth curved line, point by point.
We sent out a sign-up form through two blind institutions, National Federation of the Blind and a BLV programmers discussion list called Program L. Of the 176 individuals who filled out the form, we narrowed down our pool by excluding those who are not self-identified as fully blind. Also, those who did not have required software and hardwares. At the end, we have 11 participants who successfully finished the user study. For the 2 to 3 hour online user study, participants were asked to complete 4 sections, each dedicated to a distinct visualization. Each section includes a tutorial, task, survey, and a follow-up interview. We evaluated the usability of our MAIDR system with 11 blind participants using the system usability scale test. On average, bar plots scored 81.36, heat maps scored 75.5, box plots scored 74, and scatter plots scored 70.25. These usability scores appear to correlate with the inherent complexity of each type of visualization, suggesting that the results may also reflect the notability of each visualization. Later, we examined the system logs detailing participant usage of multiple modalities and the user state diagrams to analyze user behaviors. We identified 2 major strategies of using the form modalities in the system. One is whole to part strategy. Participants were using either sonification or Braille initially to grasp a global view of a graph or dataset before delving into the details. However, a few participants take the part-to-whole strategy. That is, starting with textual elements to get themselves familiar with the visualization before utilizing other modalities for further exploration. Our analysis also indicates that different participants choose different preference for modalities. Let's take sonification for instance. One participant who has a high-pitch hearing impairment explicitly stated that text and Braille are more useful for them than sonification. However, participants with a strong sense of pitch prefer to use sonification first to interpret the visualization. We further provide insights which should be considered when adding tactile representation to accessible visualization. Nonverbal tactile representations, although has certain limits, but they stand out because of the holistic comprehension. Meanwhile, verbal tactile representations are highly preferred by participants who aims to get a detailed understanding of data and their own speed of reading Braille. Additionally, we summarize the limitation and potential of single-line Braille displays. More details can be found in our paper. In the future, we aim to support multi-line Braille display and explore how it can address the granularity issues arise when using a single-line Braille display. We also plan to integrating our MAIDR system with the current data science environment, such as R and Python, allowing blind users to analyze dataset in a more accessible way. We have listed our GitHub repo, paper, and demo website here for your reference. If you have any questions, please reach out to us. Lastly, we'd like to pass our big thanks to the agencies that fund this project. Thank you for your listening.